Now, every time I get to section 4, every year, nobody believes me that you will be able to do every single thing that you did on worksheet 3. This is worksheet 3. You guys used a unit circle. Ideally, what my thought was is that you went, looked at the unit circle, you found the angle, and then you looked for either the x for the cosine, or you looked for the y for the sine, or you took the sine divided by the cosine to find the tangent. You were able to find all these different ratios. Now, that's good, but by the time we get to calculus, you do not have time to be able to do the calculus part if you have to draw a whole unit circle and use a unit circle to figure out what the ratios are. There are a lot of common ones that we use all the time. So because of that, you will be required to be able to do everything you just did from memory. You should be able to do everything on worksheet 3, and every problem should only take you about 10 seconds or so. And if you don't believe me, most of my students from last year, about 80 to 85% of students were able to do this if they just pay attention and follow the process that I'm about to share with you. There is another way to do it. That's what the very beginning of this lecture is. I'm going to give credit to her maiden name was Mrs. Brown from Clovis North. She teaches the special right triangles this way. So she has a different way to do it. But I've decided I'm not even going to explain it this way. It's here in case you want to see another way to do it. For example, the cosine of 45 degrees is the adjacent over hypotenuse, or root 2 over 2. You could do it this way as well. If you want to know what the sine of 60 degrees is, it's the opposite over hypotenuse. It's root 3 over 2. If you memorize these triangles, you could figure out everything just like what we just did. That's the way she does it at Clovis North. It's not the way that I do it, but it's there in case. Most students don't use her method, but some students like it. Okay, there we go. The two things that we're going to do before we start talking about actually doing problems. Some of your problems will have angles that are not in a quadrant, and the question is going to say, what quadrant is it in? If it is on the axis, just say which axis it's on. If it's 90 degrees, it's not in quadrant 1 or in quadrant 2, it's on the y-axis. If we're at 180 degrees, we are not in quadrants 2 and 3, we are on the x-axis, and that's what I mean by quadrantal angles. They are angles that are not in the quadrant. Some students use this acronym to know what's positive where. All, this is backwards by the way, all should be over here, students should be there, so I'm going to just put a little arrow. Click this, draw, all should be here. Students should be here. All students take calculus. All students take calculus. All of them are positive here. The sine is positive in quadrant 2. The tangent is positive in quadrant 3. And the cosine is positive in quadrant 4. That's a way to remember it. It's just something that may help some of you, because we're going to be dealing with quadrants 2, 3, and 4 where people get confused. So the main idea of this section is how can we figure out what the sine and the cosine ratios of all those things are. You will either have to memorize the unit circle, or you will need to use Mr. Promo's hand trick. I actually learned this from a teacher off of YouTube. I do not remember her name, and I've been using it ever since, and it really makes the unit circle very easy to do. If you try to speak to any other student about the unit circle, they will have no idea what you're talking about it, because Mr. Promo is the only teacher who teaches it this way on Buchanan's campus. Every finger on your left hand represents a quadrant 1 angle. To find the angles ratios, go to that angle and fold it down, and you're going to count how many fingers and plug it into the square root fingers divided by 2. Let me minimize this. Let me show you that unit circle. If you look at these angles, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and you see these ratios, an easy way to think about it is that every single angle is one of your fingers. Pinky, ring finger, your number 1 finger, the pointer finger, and your thumb. If you think about that and you were to go to, let's say, 60 degrees and you fold down 60 degrees, on the left side of the finger fold down is your cosine. Square root of how many fingers divided by 2? Square root of how many fingers is your sine divided by 2? If you go to the 45 degree angle and you fold it down, square root of how many fingers for your cosine divided by 2? Your sine is on the right hand side of the comma. Square root 2 over 2. If you fold down 30 degree angle, square root of how many fingers divided by 2? Square root of how many fingers divided by 2? Same ratios. And it even worked if you want to go to 0 degrees, because square root of 4 fingers divided by 2 is still 1. There are no fingers divided by 2 there if you wanted to do it that way. So Mr. Paramo's hand trick is a way for you to have the entire unit circle on the palm of your hand every single time. If we go to quadrant 2, you still use your left hand. If we go to quadrant 3, you still use your left hand. If we go to quadrant 4, you still use your left hand. The key is you have to know the reference angle. For example, if I go back to this unit circle, and now I'm going to talk about 150 degrees. When we talked about reference angles, I said, how far is this to the x-axis? And you all told me that the reference angle is a reference angle of 30. That's the angle you fold down. Here's your cosine. Here's your sine. Here's your cosine. Here's your sine. The only thing you have to pay attention to is, in quadrant 2, cosine is negative and the sine is positive. If we have 120 degrees, that's a 60 degree reference angle. Cosine is negative, sine is positive. 225, 45 degree, cosine's negative, sine is negative in quadrant 3, and so on. So don't flip your hand. The hand stays in this direction every single time. You're just looking for the reference angle. If you don't remember reference angles, it's how far is this angle from the x-axis. 300, 60 degree reference angle, and so on. So right now, in third period, what I want you to do is I want you to describe the process to your neighbor and do a quick check-in. North person and south person, we are going to do this. I don't care that I'm recording. They can fast forward. It's totally fine. You guys make sure that your partner understands how to do the hand trick. Here's how we're going to do it. Let's use 330 and 315. North person, explain how to find the ratios for 330 degrees. This is north person. South person, explain how to find 315 degrees ratios with your partner. Discuss, please. Go.
So 330, so my hand, 270, 315, 330, smack that one down.
Because this is cosine. This is sine. And then 315 is 45 degrees. So you put your middle line down. 2 and cosine. I have a question. So like for that fourth quadrant, would 330 be the 30-degree angle?
Yep.
Okay, that's okay. Yeah. Because you're counting it from bottom to top, but it's really it's from 0 to 90 in that quadrant. Yeah, so it'd be down.
So then, would it be?
So yours would have been 30 degrees.
So would it have been 80 to 270 on the other one instead of 270 to 80? Would it be 80 to 270 or 270 to 80 for the hand? The other one.
So, in case you got confused, 330 has, we're always saying, what would the positive acute, like if I were to draw this triangle right here, if I draw this triangle, we're looking for the angle formed to the x-axis. How far is 330 degrees from the 0 degrees or from the 360? Same thing. It's 30 degrees. That's this angle right there.
So 215.
Root 3 over 2, 1 over 2, except the sign is negative in quadrant 4. If I had the 315, how far is it from the x-axis? It's 45 degrees. So root 2 over 2, and then root 2 over 2, except the sign is negative in quadrant 4. That's what it should be. And those don't take that long to do. So as we're doing our examples here, you're using all these reference angles. You have to draw them and do several examples, and you should be able to do them fast. For example, if you have number 3, it says cosine of 120 degrees equals, you sketch the angle, 120 degrees. Past 90, but not to 180. It's right about here. It's in quadrant 2. What's the reference angle? The reference angle is how far is it from the x-axis? I know that that is 60 more degrees to the x-axis. That's the finger you would put down. Cosine is your x. I look at this and I say, oh, I know how many fingers I have on the left side of my comma, or the finger that's folded down. If you're thinking it's 1/2, you were close. It's negative 1/2 because the cosine is negative in quadrant 2. The number one mistakes that students make, is it positive or is it negative in the quadrant you're looking for? I sometimes check that first. 120 is here, cosine's negative in quadrant 2. The sign is positive. Your x is negative, your sign is positive. And that shouldn't take you that long. As a matter of fact, as I do the next one, I'm going to do one more with you. 240. Quadrant 3. 60 degrees past. It's negative in that quadrant. I always ask myself, is it negative or is it positive? And sign is negative in quadrant 3. Now that I've done 2 of them for you, see if you can do the tangent of 225 and the sine of 90 degrees. And how about the north person does the top one, the south person does the bottom one, and then you check each other's work and do both, but north person, you're in charge of the top one, number 19, and south person, you're in charge of the bottom one. And then discuss. Go ahead. I'll give you some time. Show of hands for me, please. How many of you got number 19 correct and number 6 correct? Raise your hand so I can see how many. Perfect. There's not everybody, but my class, just so you know, 225, quadrant 3, it's 45 degrees past 180. And then if you're doing the sine divided by the cosine, some people get confused. It's root 2 over 2 divided by root 2 over 2. But guess what? What is 2 divided by 2, or root 2 over 2 divided by root 2 over 2? It's 1. It's just as easy to do it on your fingers as it is to do on the unit circle. If you're talking about 90 degrees, you either think of the location or you fold down the 90. Root 4 fingers divided by 2 simplifies to 1. Don't forget. Your goal is no calculator, no unit circle. Do all the problems from memory or using the hand trick. It should take you 10 seconds or less every problem. Okay? That's where I'm going to end your notes.